Hi, welcome to this session on functions, modules, and recursion. First, a brief recap of basic facts about functions. So we have the following syntax for introducing functions in a code. We start with the usual keyword def, then we give the name of the function, and all the parameters that the function consoles are put within parentheses. Following this, we have a set of Python statements to carry out the task at hand. And if there are variables to be returned to the main program for further processing, we may use a return statement. So this is the basic structure for defining a function in a Python code. Now let us look at two simple examples. One on the left is defining a function to draw a circle. The one on the right defines a function which will calculate the area of a given circle. Now the difference between the two is the following. The one on the left, the program starts not with the definition of a function, but rather with some Python statements. The one on right starts with the definition of functions, and then there are Python statements which will invoke this function. So the message is, it is not that every code has to start with all the definitions listed out at the beginning, and then you have the main code. The definition of function can occur anywhere in the code. The important point is that before you invoke or call the function, it should have been defined. So that's the key point that you should carry with you. There are certain subtle aspects that we should be aware of if we want to avoid unnecessary pitfalls. Look at this simple code which does the job of swapping two numbers. So if you are given numbers 1 and 7, after this program is executed, it will return numbers 7 and 1. That is in the reverse order. So when we invoke the function in the last statement, that's where we call the function. It assigns the value of x to a and the value of y to b. So you have already defined the value of x and y to be 1 and 2 respectively. So these two values are now assigned to a and b, and the function swap 0 carries out the task of swapping the two numbers. Remember, we are assigning these two numbers to two other parameters p and q. So what are the relevant questions that we can ask? Of course, we need to ask what are the values of x and y at various points as the program is executed. So I have introduced some print statements within the program so that we understand what's really going on here. So the first print statement occurs right after the assignment of x and y, that is 1 and 2 for x and y respectively. And after this, the function is called, that is st is equal to swap 0 x comma y. So once this statement is there, the program, the code gets into the function and starts executing the statements within the function. So the next print statement comes within the function swap 0, and the final print statement is at the end of this code. So these three statements will tell us the value of the function before the value of the parameters x and y before the function call, within the function, and after the function call. So let us look at the results. So it remains 1 and 2 in all the stages, that is before, while, and after the function. So there is no surprise here because our variables are x and y and the function parameters are a and b. Now let us make a mild modification in this code. So the variables still remain the same, x and y, and I have set the values to be 1 and 2 respectively. But the function parameters are also x and y. So the variables as well as the parameter that I have specified for the function, both are same. Now if we run this code, after introducing the relevant print statements, what do you get? So before the function is called, of course the values are 1 and 2 for x and y respectively. This is what we have specified. Within the function routine, if you see, the value of x is 2 and y is 1. That is, the values are changed. After the function call is over, that is the code exits the function, the values of x and y revert back to the original values 1 and 2. So this is something that you should keep in mind. Though the function depends on parameters x and y, which are exactly the same as the variable that we specified in the main code, and these values do get altered within the function, they are not changed as far as the main code is concerned, because the function exits and the values are lost. So this is called stacking in Python. So whenever you invoke a function, it identifies a new set of memory location for it to store and process these values, and as soon as the code exits that function, that sector in the memory is lost. So it is not under the control of program anymore. Is it that we can never assign the values or the changed values within the function to the value for the main code? It is of course possible. All that you have to do is to introduce an assign statement. That's what is done here. So instead of saying p comma q is equal to swap xy, I simply set xy is equal to swap xy. So here, even though the value of the function, the values of the variables x and y are changed within the function and they may not be available to the main code, by this assignment statement, I will ensure that after this, the values of x and y will be the values exactly that they were within the function. So here is the result. So before the function call, it is 1 and 2. Within the routine, it is 2 and 1. And after the function call, you see it is exactly same as what we have within the function routine. So this way we can actually change the values of these variables x and y. They are actually outside the function. So this is a simple exercise for you. You can try it when you have time. So let us look at another example. So this is a code which is a bit more complicated than the previous two examples. So I have two functions defined within this code, one to draw a circle and another to draw a polygon. The purpose of this code is it will ask you for an input whether you want to draw a circle or a polygon. And once you make the choice, if it is circle, it will ask for the radius. And if it's a polygon, it will have two parameters, one the number of sides and another the length of side. So it draws a regular polygon. So this program, if you execute, I have made the choice of polygon with 7 sides and the length of each side being 75, and here is the result. So defining functions and writing a Python code which will invoke all these is not a very difficult task. So that's the message that I would like to give. The important point is this. So you should keep this in mind whenever you define your variables. Just because you have used the same parameters as the variable, it doesn't mean those values within the function are available to the code. You have to necessarily make an assignment statement outside if you want the changed value to be used for further processing within the code. Now let us look at recursive function. I have given 3 examples here. Maybe by studying these examples, you will understand what a recursive function is. The first one is, of course, is sum of n natural numbers. So I use SUM to denote the sum of first n natural numbers. So if I want to sum, let us say from 1 to 10, then sum of 10 numbers is essentially 10, the last number, plus sum of the remaining 9 numbers, 1 to 9. So now sum of 10 numbers is written in terms of the sum of 9 numbers and a parameter. It happens to be 10 in this particular case. Now what is sum of 9 numbers? It is 9 plus sum of the first 8 numbers. So it continues like this all the way up to sum of 2 numbers, which is 2 plus sum of 1 number. Sum of 1 number is the number itself. And now if you look at the general structure here, or if you want to extract the general structure from this, the quantity at nth stage is expressed in terms of the values of this quantity in the previous stages. So it could involve just one stage, as in this example of sum of n natural numbers, or it could involve many previous stages. So some quantity at nth stage may depend on the value of the quantity at the n minus 1 stage, n minus 2 stage, n minus 3 stage, and so on and so forth, maybe up to, or not necessarily all in that order. It can be sum of 10, a quantity in the 10th stage may depend on quantity in 9th stage, 4th stage, and 3rd stage. So it can also occur in such um, varied combinations. Another example exactly fits to this structure is the random number generator. So the random number at the nth stage, or the nth random number, is generated out of the previous random number by this expression given here, which involves three parameters A, B, and D, which are specified by the user. And this percentage symbol stands for modulo arithmetic. Essentially, it gives you the reminder when the quantity A rand plus B is divided by T. So now, once again, you see the random number at the nth stage is extracted out of the random number at the n minus 1 stage. So you do some manipulation with the random number at the n minus 1 stage to generate the random number at the nth stage. Similarly, the square root of a positive real number is obtained by the following recursion relation. So it is not that you have so many roots to calculate. It is the improvisation of a root to its actual value. So the square root of a positive real number at let us say n plus 1 stage is expressed in terms of the square root of this positive real number at the previous stage. Now in all the previous, that is the two examples before, we had just a simple combination of the previous stage values, either with addition to some parameter or some combination of multiplication by a parameter and addition. But here you see this root n, that is the previous stage value, occurs in a nonlinear way. It occurs as root n. It also occurs in the denominator. So it's a very nonlinear process that way. But it fits into the general scheme that the value of the root at the n plus 1 stage is a function of the value of the root at the nth stage. So I have implemented the first one, the sum of natural numbers, in this Python code. Now you realize that the name of the function is sum n. So n is the parameter on which the function depends on. And if you get into the code, you see that it depends on sum at the previous stage n minus 1. So if I start with n is equal to, let us say, 5, of course the first if statement will not be executed because n is not 1. So it comes to the next if statement. Here it requires sum at n minus 1, which is sum at 4. Therefore it gets back to the definition of sum and finds that n is equal to 4. Therefore first statement is, if statement is not executed, it comes to the next if statement. Then it finds that it requires sum at n equal to 3. n minus 1, n is already 4, therefore n minus 1 becomes 3. Therefore it continues this process till it gets at n equal to 1, in which case the sum becomes n itself as specified by the first if statement. So this is the way we code recursion relations in Python. And this code, if you run, of course I'm giving input number of 11, that is I want to sum the first 11 numbers. The answer is 66, which you can readily verify. Now I have also implemented the random number generator in this simple code. The important point to note is the name of the function is rand underscore gen. It depends on 4 parameters. 3 of them are user specified ABC, and n is the index that we have here. Now you see that random number generator at stage n relies on the random number generator value at stage n minus 1. So that is the recursion relation that I was referring to before. I have run this code with this value that I have given here for A, B, C, and n, and I am expecting it to print about 40 random numbers, and here they are, these 40 random numbers. Of course, you will realize that this, because it is modulo division by C and the value has been chosen to be 117, it will generate random numbers in the range 0 to 116. Modulo arithmetic by D will never generate a value beyond D minus 1. Therefore, it is 117 here as the divisor in the modulo arithmetic. Therefore, it will generate random numbers up to 116. Okay. So for practice, maybe you can try to implement this in code. What have we seen? We have looked at certain aspects of function. how to write a modular code so that it looks simple and it is easily manageable, and few examples above on recursion. Thank you.